Yeah, it's time. Please take the seat. Okay. Ladies and gentlemen, good afternoon. It's my honor to coordinate the last session of today and also a very special one, the industry session. We invited 5 speakers from Chinese companies, including Amino-Chem, Sinopec, Chem, and Petro-China. You may heard about it, Sinopec, Petro-China, and Wanhua. They are probably the top 3 or 4 chemical engineering industry company here. And also Amino-Chem, this ranks #1 in the fine chemical industry in China during the past decades. And we are very happy to organize this special industry session to have communication between academia and the industry people. Yeah, we may have a gap between these two, but I think it's our job to build, to bridge the gap. And this is a chance or try here today. So let's start from the first speaker, Mr. Gong. Mr. Gong is the CEO of Amino-Chem, and he also founded us to build the smart manufacturing joint lab. And okay. Sorry. For each presentation, it lasts for 20 minutes. Okay, I will remind you 5 minutes ahead of it later.
Thank you for the introduction. Amino-Chem, we on July 11th, 2020, we have a joint venture with Zhejiang University in our plant. That is that area is control room, central control room of our plant. The objectives of the center is to improve Amino's leading position in industry of fine chemicals through the collaboration with Zhejiang University for its technological innovation, international cooperation, and talent cultivation and managers. Explore new technologies, improve plant operation, and enhance market competitiveness. Establish a demonstration model for joint R&D center between academia and industry. For us, it's very simple to make money. Research plan focus on digitalization, automation, and smart manufacturing of process industries, and towards quality, safety, energy saving, and emission reduction. And undertake innovative research on developing of new methods and reliable technologies for process modeling, control, optimization, and monitoring, and diagnosis. These are 7 projects we had together, and I will introduce 5 of them. First is digital twinning system of nitration process on thermal safety. As Professor Chen has already introduced, this is a major project during our cooperation. Data is the foundation. We provide sufficient data to the model, and also model is a core, software is a carrier, and we have 3 deliveries from the collaboration. One is the operator training system, OTS. One is online monitoring system, OMS, and the last one is offline analyzing system, OAS. So these two softwares are for 3 layers of people. The OTS is for operators. And online monitoring system is for the engineering. And OAS is for the decision maker. This is the structure of the OTS system. So the operator can use a visual DCS. The visual DCS is a digital twin of the real DCS. So they can practice their skills offline to improve their skills to operate. And this is an example of video how to can you run the OTS system?
没有声音。
So it's a real scenario in an operating room. You can make a stop.
往下背头就行。
And the OMS is an online computing software. This is very important, as Professor Chen has already explained. We have real-time data to the OMS, and then we get data extraction and online evaluation for the operations. The OMS will provide a 5 minutes ahead temperature prediction, which is key to our operation, because as mentioned before, that nitration is a very dangerous process. So 5 minutes prediction ahead is very important to the operation. And also, the OMS can provide online computation of the 7 reactors. So the engineers, they can know the nitrogen rate in each reactor and also the nitric acid concentration in each reactor, which are very critical to the nitration process. This is cockpit image of the OMS. So from here we can see the nitration rate and the nitric acid concentration, and also the 5 minutes prediction of the temperature. This is system architecture of OAS. It provides the user, the decision maker, with software to do the simulation offline. So it's like this. The software, the decision maker just input operating conditions like temperature, loading, and then we do the simulation and get the output. Because it is very critical to upload or download the raw material in our real time in our real nitration process. So the simulation help us to also guide us to get a better output. So this is a kind of simulation step by step. This is the second project we cooperate. It is online ramen analyzer system. The system is high temperature resistant and the maintenance is actually free. You don't have to maintain. And also we use a multi-channel online ramen instrument system, which significantly reduce equipment costs. And also, when the model of the analysis established, it is no need to change the model parameters, so it's easy to operate. From these three pictures, you can see it is very accurate to use the analyzer system. On this project, we use a visual inspection system for sight glasses. During nitration, we also have to ask our operators to check the sight glass to see if there is any abnormal situation happen. So here we have two guidelines. One is liquid level, and another is the color of the nitration materials. So where is the liquid level or the color get to the threshold, alarm will be sent to operators in the control room. So basically, the workers, they don't have to go to the site to check the sight glasses. This is also an online visual inspection system for sight glasses, which is used in our wastewater treatment. We use activated carbon as one of the to treat the wastewater, but the leakage of the activated carbon get a serious problem in our process. By using this detection system, we can easily find the abnormal situation in our process. And this one is online monitoring and tuning management system for PID loops. In Amino-Chem, we have more than 4,000 PID loops. So how to manage them is a critical task for us. So we use automatic management of PID loops, which can check the quality of the PID loops automatically. And also, with this technology, we can control with monitoring the loop and tuning the software, tuning the loop automatically. By implementing this technology in our plant, we significantly reduce the deviation of our control and reduce the number of alarms. The last one is MPC for the distribution towers. With the online ramen analyzer at the top of the distribution column to measure MPD and PPD components. A soft sensor technology is used And the MPC combines identification method along with the latest three-term programming technologies. By implementing this MPC to our distillation towers, our products compositions are well controlled, which is less deviation, the quality, and also it's very close to the limit. And in the meantime, the energy is energy saving is significant today. We can see the boiler's duty is much less than previous condition. So that's all. Thank you.
Thank you.